Good morning, good afternoon, good evening, wherever you are. So me, Gift, and Lindelani, we just want to give you a quick rundown of our experiment for the Prac 5 of the EEE3096 course. Let's begin. For our practical, the main idea was to play around with ADC and see some of its metrics and how it operates. So in going along with that, we decided to divide our labor as can be seen by the table. Each one of us had a theoretical aspect, like Lindelani with the flowchart and me with the second diagram, and then each of us did a coding assignment. I was responsible for setting up the ADC and the button functionality, and Lindelani implemented the threading functionality, which then pulled the ADC and getting the values from the two sensors which we had in the practical assignment. So for our experiment, our hardware can be seen as by the circuit diagram in front of you. We had a Raspberry Pi and our ADC, the MCP3008, and this was our temperature sensor, the 9700. We also connected a Light Dependant Resistor, as can be seen by the circuit, and both these were hooked up to the ADC on different channels. Pin 1 in this case was channel 0 and pin 2 was channel 1. For the ADC itself, it uses an SPI interface. Therefore, the pins 10 to 13 responsible for the SPI communication were connected to their respective pins on the Raspberry Pi. Aside from this, we also had a button connected to pin 16 that was responsible for toggling on the Pi, which would change our sampling rates from either 10 seconds to 5 seconds to 1 second according to what we wanted. Let's begin our program here. So this is a flowchart showing the operations of the program as it's moving forward. So initially we set it up, and this is just setting up our environment, getting our ADC ready, getting our temperature sensor and our LDR channels set up. Aside from that, we're also setting up our buttons, commands, and the triggering for such. After that, we call the value stored method, which I'll explain a bit further on. But for the time being, let's focus on the left side. So on the left side is our interrupting handling logic. So basically, we have three types of interrupts. The first one is if we press our button to toggle or change the switch. If that happens, all we're gonna do is change the sampling rate, and then we finish handling the interrupt as it is. Aside from that, we can have a situation where we want to close our program. In this case, Control C is our command for exiting the program, and then in that case, our program will just print a simple farewell message and then clean up the GPL pins and stop the program. The last scenario would be if some other error happened, which we can't predict, and then in that case, we just output the error to the screen, clean up our GPL pins, and then move on again. Going deeper into this value stored method again, we can see the flowchart on the right. So initially what we do is, based on the sampling rate, we're going to make a new thread, and this thread is going to run at a delayed point in time. So let's say it's 10 seconds. It's only going to trigger that thread after 10 seconds have passed, and then after we've said that, we're just going to leave it be. And then in our current thread that we're operating on right now, we're going to read in the values stored in the ADC for channel 0 and channel 1, which are our LDR and temp sensor respectively. And then we're going to convert the value of the temp sensor to the respective temperature and output the values to the screen for both the two sensors. After that, our thread will end. But since we've spawned this new thread that starts after a delay, after the time for the delay is over, it's gonna trigger again the value stored method to be called, and then the same process is gonna repeat itself. So effectively, we have a back and forth occurring between the two threads, and then that's when we have continuous reading from the system, and that's basically how our program is working. And from that, now I'm just gonna go to the next video where you will see the program in action, and this will hopefully clarify some of the faster parts in the explanation.
Okay, so we need to lower the light, make it dark, so the voltage increased, and bring it back to normal. Let's make it a bit more brighter, so it decreases. Okay, now temperature, I'm just gonna hold it. Yo, I'm so cold. Okay, now it's increasing because I've been here for too long now. And let's change the sampling rate. 5 seconds. Okay, take it to 10. Okay, maybe back to 1. So this last 10 seconds one. Okay.
So in conclusion, as may have been seen by the previous feature of the experiment, we consider that all the tests we had were passed. The LDR was behaving as expected when we increased or decreased the brightness, and our temperature readings were matching what we're expecting as we were going to thread. We also noticed that our runtime thread checking was operating as we wanted, and it would trigger in the thread that was expected. If we're going to consider possible improvements to the experiment, though, we would like to see how our ADC responds to lower sampling rates than 1 second. Would it still be able to keep up, or would we see some issues happening with our values? Aside from that, we never really went deep into investigating the error of our actual output values from our two sensors. We just kind of took it by faith that that's what happened. And aside from that, our temperature sensor, when we did check the datasheet, we do know that it is prone to self-heating at the junctions as the ambient temperature changes. But that would be a nice check to see how much that total results over time. Thank you very much. Yeah, that's all, folks.